going to talk about seasons. We're also going to talk about what causes day and night. The Earth-Sun system. Earth's rotation. It takes the Earth 23 hours and 56 minutes to rotate just once on its axis. This is what we refer to as a day. Now, this does not mean that we're only referring to the daylight hours. We're simply referring to the time that it takes Earth to rotate just once on its axis as a full day. In this picture, you can see as Earth moves along its revolution around the Sun, it is also rotating or spinning on its axis. Now, the side of the Earth that faces the Sun gets sunlight, and this is called daytime. The side of the Earth that faces away from the Sun is dark, which is then called nighttime. Pretty sure you're familiar with this concept. Now, Earth is tilted. Now, the seasons are caused mainly by the 23.5 degree tilt of the Earth's axis. So during the summer months, the northern hemisphere has warmer temperatures and longer days because it is tilted toward the Sun and receives more direct solar energy. And in the winter months, the northern hemisphere has lower temperatures and shorter days because it is tilted away from the Sun. We'll see this in the picture. So here you can see that during the summer, on June 21st, that the northern hemisphere here is pointing toward the sunlight and is receiving more direct rays. But in the winter, in December, we are now pointing away from the Sun and are receiving less sunlight directly. During the fall and during the spring, we are tilted neither toward nor away, but directly pointing at the Sun. So our temperatures are in between that of summer and winter. The Earth's tilt and shape affect the amount of sunlight an area will receive. The season's yearly cycle is caused by Earth's tilt and revolution around the Sun. So here's our picture again. Here's a better example. In the previous picture, it almost looks like during the fall and spring that the Earth is above and below the Sun, when that is not correct. What's really happening is the Earth is moving around the Sun in an orbit. During the fall and spring, we're simply on either side of the Sun, not above and below it. Now, some places on Earth do not have a lot of seasonal change because of their position in relation to the Sun does not change. So, along the equator, temperatures and the amount of daylight stay the same year-round. You can see in this picture where we have our sun rays at the equator are pointed directly on the equator, and it is getting a large amount of sunlight direct. However, that same amount of sun rays hitting in the middle of the Earth are spread out a little bit, here and here. And the same amount of sun rays at the poles cover a larger area of the Earth's surface because the Earth is round. So here is a video that'll better describe this interaction.
Imagine that you live in North America, and one day you call up your friend in Australia. You guys are talking and you make plans to go visit him next summer.
So,
the important thing, for the seasons at least, is that the Earth actually isn't straight up and down. It's tilted at an angle of 23.5 degrees. So, when the Earth is on this side of the Sun, the northern hemisphere is angled away from the Sun. The southern hemisphere is angled toward the Sun. When the Earth is revolving around the Sun, it stays tilted in the same position. The axis doesn't wiggle around or anything. It just stays fixed in a certain direction. So when the Earth is over here, the northern hemisphere is angled towards the Sun, and the southern hemisphere is angled away. When a hemisphere is angled towards the Sun's rays hit it directly. That's what's happening in the northern hemisphere here. But when a hemisphere is angled away from the Sun, like the southern hemisphere here, The sun's rays hit it indirectly.
Okay, so what difference does direct or indirect sunlight make?
Oh, there's a huge difference. Let's take a look with a simple experiment. In this experiment, we're going to use a flashlight to simulate the sun. Say that the flashlight is a particular sunbeam. If it's shining directly, all its energy is concentrated in a certain area. But if the sunbeam is shining indirectly, the area is larger. This means that the same amount of energy is spread out over a larger area. So, in a particular point on the paper, it feels colder in the indirect sunbeam than in the direct sunbeam. And the more indirect the sunbeam, the larger the area. It's important to note that the amount of energy in the sunbeam is always the same. It's not changing. However, if it's spread out over a larger area, we feel it less.
So this video shows you the concept that I was talking about on this slide, with your direct rays being at the equator and the sun's energy being highly concentrated, and at the poles, that same amount of energy being spread out over a larger area. So what I would like for you to do is practice labeling your seasons for the Northern Hemisphere as shown in the picture above. So what season is A having? What season is B having? What season is C having? And what season is picture D having? Write your guess on your paper. Now let's check your paper and see if you are correct. Season A is the fall. Season B is spring. Season C is winter. And Season D is summer. So how can you tell the difference between spring and fall? Well, there is a particular trick that I can show you. If you look at Season D, we know that this is summer because the Northern Hemisphere is pointing toward the sun. If you remember from previous grades, the Earth moves counterclockwise, which means we're going to go from D over here to A. And what season comes after summer? Fall. And then, as we continue to move counterclockwise around our orbit, the Northern Hemisphere is now pointing away, which means we are now in winter. If we then continue to move counterclockwise, we come to this position. And what season comes after winter? Spring. So as long as you remember that spring comes after winter, and that fall comes after summer, and that the Earth is moving counterclockwise around the sun, you should be able to correctly label both fall and spring on any picture. So let's try again. This time, let's label the seasons for the Southern Hemisphere. This time, we're going to start with B being fall and A being spring. Notice that for the Southern Hemisphere, they have swapped. This also means that D and C have swapped. This time, D is winter and C is summer because we're talking about the Southern Hemisphere. The Southern Hemisphere is always going to have the opposite season that the Northern Hemisphere does. So in picture C, the Northern Hemisphere is pointing away. So the Northern Hemisphere has summer, which means the Southern Hemisphere is pointing toward the sun, and so they will then have summer. And the opposite of winter is summer. The same case here. The Northern Hemisphere is pointing toward the sun, is having summer, which means the Southern Hemisphere is having winter. And as I said before, what season comes after winter? If you move counterclockwise to spring, and then you have summer, moving counterclockwise to fall, because fall comes after summer. That is all for now. Make sure that you have your notes and place them in your folder so that way you have them for tomorrow.